Hello, today's topic is going to be Unit 3 for the AP people. For us it was Observational Studies and Experiments. So we're going to go ahead and look over this stuff. Now I have to warn you that I'm not actually reteaching this because this was like 7 to 10 days worth of stuff. So all I can do is kind of throw this out in front of you, highlight some of the issues quickly, and then rely on you to explore further anything you just don't feel very strong about. So we're looking at observational studies and experiments. So starting out with observational studies, these are studies where nothing is imposed. You're just kind of passively recording data or information. And we're going to start out with the bad ones, the ones that aren't very defensible. And the first one you'll remember was convenience sampling. So if you picture somebody in a mall with a clipboard just grabbing people that walk by, that's kind of a lazy thing to do. You're getting a sample, you're getting information, but you may be working bias into the mix. You know, bias, remember that is missing the mark. Because when you've got people in the mall, whatever you get for your conclusions or your results from your study are just going to apply to people that are in the mall. People that don't go to the mall, their views will not be included. So that's one. Voluntary response, that's where you just throw out an appeal for people to respond, and they do so. That's a real problem because people with strong opinions are going to be overrepresented. It's a lot better just to get a mix of people, something that will generalize or represent the population that you're trying to get information from, so that your information actually will generalize to it. It's sort of like if you put up a Fox News poll that says, how much do you like President Trump, rated on a scale from 1 to 10? You're probably going to get most people with 8s, 9s, and 10s. But if you did the same thing with MSNBC, you'd probably get 0s, 1s, and 2s. So you just get the strong opinions represented. So both of these have issues with bias and defensibility. In other words, you can't really have this peer-reviewed and expect to get a lot of people patting you on the back and telling you what a great job you did. The problem is that not everybody in your sampling frame has the same chance to be chosen to participate. So remember, bias is missing the mark. A better option is probability sampling, and we spent 2 days at least on this. But in general, you can pretty much say for all the little methods that fall under the heading of probability sampling, they'll give everyone the same chance to be picked. The first one we covered was simple random sampling. Now remember that it does give everybody the same chance to be picked. But remember specifically, it gives every group of n individuals the same chance to be picked. So if I've got a sampling frame of 50 people to pick from, and I need a sample of 10, if I do it with a simple random sample, every possible group of size 10 in that larger group of 50 will have the same chance to be picked. And then by extension, that means everybody has the same chance to be picked. All right, stratified random sampling. That's when you look at your sampling frame and go, ooh, I've got maybe 3 or 4 or 5 people in this group that have a certain characteristic that I want in my study, but I may miss them if I just do a simple random sample. So say it's by income, and you want to make sure that you get people that are lower SES, and you've got like 5 out of 50. And you just feel like you're not going to get good results if you don't get at least 1 or 2 of those people. So you just split up by some categorical variable, which would be income, and you set up, certain income levels to have certain strata, like you'd have poor, lower middle class, upper middle class, and perhaps wealthy. And you would take simple random samples of smaller sizes from each of those subdivisions to make sure everybody was represented. All right, systematic random sampling. Remember that when you do this, you pick a random starting point, and then every 5th person or every 10th person or every 15th person. All right, this is a pretty good way to sample, but it does suffer from things that may be cyclical in nature. Remember, I used an example of a production line that is producing something well, and then the next thing is well, and then the next thing is well, but the 4th thing ends up like there's a hiccup in the machine, and the 4th thing comes out defective, and then it just kind of snaps back and repeats that process. You could get a sample that had too many defective items, or you could get none at all, depending what your starting point was and what the interval was that you were sampling. So that's a little issue with systematic. By the way, stratified is probably your most accurate out of the 3 up here. All right, multi-stage, remember that was something that we used for a national, although you can use it for other kinds of surveys, but a national survey where you want to represent a good cross-section of the country, but you want to be able to do it without throwing 300 million people's names or numbers into a hat and then picking a sample of 100. So what you would do here would be to break the country down into counties or parishes, take a simple random sample of them. Then within each county, you get to a smaller geographic arrangement. So you would take a simple random sample of townships. And within that group of chosen townships, you would take a simple random sample of blocks. And then within each block, you take a simple random sample of households. Then you should get little tiny groups of households all over the place, and you can send, surveying folks, interviewers out there, and they can just go to each little cluster rather than doing one house in Maine and one house in Texas and then another in Florida. All right, that's multi-stage. That's just sampling down in smaller groupings until you get ones you can handle. And then cluster sampling, say you have a state like Texas and you want to get a cluster sample. Well, you would just take a simple random sample of the counties, and then you'd have to go and get information from everybody within the chosen county. That's your cluster sampling. All of these give everybody, at least at some point in the process, the same chance to be picked. So these are going to be defensible and good for professional studies. So by the way, anything that's done by a Gallup poll or PBS, Gallup, I guess would be together, New York Times poll, or any major poll that stakes its reputation very highly is going to use probability sampling. All right, remember, however you choose the group, you want it to represent the population as close as possible. So, if you need information about all the seniors in all the schools in KDISD, you're not going to just want to get a sample of seniors at Cinco Ranch. You're going to want to get at least some from every high school, so that sounds like you would stratify that. All right, so if the AP people want to know, if they want you to describe how a sample is chosen, number one, let's just throw out random digit tables. I don't recall ever seeing one in an AP exam, not even in the tables and various charts and things that they provide for you. So what I would do is just mention a random number generator to pick numbers you've assigned to each individual in your sampling frame. So assign digits to those in your sampling frame, use a random number to choose participants. If they actually want you to do it, it's random integer on your calculator. You can practice that, but typically they're just going to want you to describe it. And in this particular administration where you only have 45 minutes, I doubt you're going to be using a random number table or your calculator to pick things randomly. You can just describe how you would do it. If you need to fill two groups, like one that gets a treatment and one that doesn't, just take your sampling frame, choose how many you want in your first group, and then the remainder, like half in the first group and whatever you didn't pick, go in the second group, and they're considered to be random too. All right, so sources of bias, this is some of the terminology that we had learned. Under coverage, this is where you just can't get to everybody in a particular population of interest. Certain people are systematically left out. That's like the mall. Non-response, right? These are people who can't answer or who won't answer. And you can see that there's going to be a little overlap between the two, because if you have groups of people who can't answer, like they're at work and you're doing a telephone poll, then that's non-response, but you can argue that's under coverage. Response bias, this is where people either don't remember correctly when they're answering or they're just flat out lying to you. Wording effects is where you confuse people or you say things that actually motivate them to answer. Remember when we did the project in the fall, we were trying to make people lie, so you threw in words that kind of forced them into lying. That would be wording effects. Oh, and just FYI, wording effects aren't there just to make people lie. You can say something like, all of those, I don't know, dachshunds, are terrible and they're hard to train and they chew up everything and they have accidents in the home. Given all of that, would you be interested in a dachshund? All right, so no offense to you guys that own a dachshund, but people who read that are going to be like, nah, I don't want that dog. A better way to word it would be, do you want a dachshund? Do you like them? All right, experiments. This is a type of study where a treatment is deliberately imposed and an effect is measured after that imposition. So remember, the studies we did before that didn't impose anything. So experiments can give evidence of causation between explanatory and response variables. Explanatory is what you impose and response is what you measure. All right, remember, experimental units or subjects, these are the items, are the people that the experiment is performed upon. Subjects are people. Factors and levels. Factors are those things that we impose. Levels are subheadings for that. We'll see this in an organizer in a moment. Treatments, these are the specific things that are being imposed upon different groups in your experiments. All right, so here is a two-factor experiment. Factor one is drug. There's a control, or A and B, so maybe sugar pill, aspirin, Tylenol. And the other factor is physical state with a level of rested and tired. All right, so each combination of those things require a group. 3 times 2 equals 6 unique treatments, and each unique treatment requires a group. So group 6 is getting drug B and they're getting naps. And group 2 is getting drug A and they're being kept up at night. All right. Now this is not a design of an experiment. It's just an organizer to help you get started. We have 4 principles of experimental design: control, randomization, replication, and, sorry, that was my favorite caller, scam likely. So let me start back. Control, this is where we want to set up a situation where every variable except the one we're interested in can be somehow controlled, so that when we get our results, the only thing that we can attribute to the results is our experimental variable. Randomization, that ensure groups that are of equal characteristics. Replication, you just don't want to do an experiment on 1 or 2 people. You want to do it on many people or many subjects. Replication can also mean if you see an effect in one trial of an experiment, you might want to do 2 or 3 other ones to make sure that that keeps happening. And then blocking is just that way of separating individuals or experimental units by a characteristic, like doing an experiment concurrently, once on women, once on men, once on Caucasian people, once on non-white people, whatever, all right? Blocking is a lot like stratifying, but stratifying is for a study and blocking is an experiment. All right, here's a completely randomized design. We're checking out a new diet as opposed to the current diet to see weight gain at the end. So we take 30 rats, we randomly allocate them. And if you recall this, they were male white rats, so we actually had control for that too. We randomly assign them into 2 groups of 15. They don't have to be equal. And remember, the random allocation will ensure that if we have, rats that gain weight faster than others, that they'll be sort of randomly assigned, and so that'll make your groups sort of identical, hopefully. Treatment 1 is the new diet, treatment 2 is the standard, and at the end you compare the weight gain. You can say it in words. All right, here is a block design. I'm not going to read the whole thing to you, but let's see. You blocked by which store these tomato plants came, but you're basically running the same experiment twice. So you don't look at this and say, oh, there's 6 treatments. There's actually only 3. They're just being replicated twice. And then you can get more detail based upon any extra variation that you've controlled for by blocking by store type. Typically you don't compare between the blocks because then you lose the control that you built in by doing the blocks in the first place. All right, a matched pairs design. This is where an individual serves as their own control, typically, or you do treatment on 2 treatments on 1 individual's. In this particular case, you can read this, but I believe what they end up doing is they're trying to see if color will attract these cereal leaf beetles, and so they put these sticky pads on poles, but they're putting different colors, and they just kind of flip a coin to see which color goes on top, and that way they're controlling for a lot of different things, especially in this particular case. It doesn't really matter, I can't think of anything. Go ahead and read this, but basically that's how it works. All right, this just went all by itself. One thing we can do to control is the placebo effect. That's where you just impose a dummy treatment, and what that does is that your 2 groups are going to respond to your treatments, probably positively. Like, people will take a pill and they will expect to get better, and they will get better. So you want a dummy pill so that those people get better, and then for the other pill, the treatment pill, they'll also get better just because they're taking a pill. We're just trying to see if that real treatment gets even better, results beyond that placebo effect. Blocking, we've already mentioned, is a form of control. And then we have blinding. Remember, we had single and double blinding. Single blinding is that the patient doesn't know what kind of treatment that they're getting. And double blinding is where the patient doesn't know what kind of treatment they're getting, and those people involved with the patient, like people delivering the medicine and whatnot, they also don't know what treatment is being delivered, because they can contaminate by saying anything like, yeah, Edith, you're actually getting the good stuff. If you say that to Edith, she's going to feel much, much, much better whether there was a real effect there or not. Okay, so there's 3 different ways of controlling. All right, so that was really quick. Certainly you could pause anywhere you wanted to, replay it and look it over, and if you think, I'm not really clear on how these things go, you can go back into the original PowerPoints and the videos and look them up. In the meantime, I've got some examples here. Just want to kind of run across. All right, so these are actually, I think most of them are from old AP exams. I know this one is. It's been modified a little bit, but let's go for it. So an apartment building has 9 floors and each floor has 4 apartments. The building owner wants to install new carpeting in 8 apartments to see how well it wears before she decides whether to replace the carpet in the entire building. The figure below shows the floors of the apartments in the building with their apartment numbers. Only 9 apartments indicated with an asterisk have children in the apartment. All right, so is this an observational study or an experiment? Before I answer that, if you want to, you can pause this video, print this out, and work this and see how it compares to my answers. So go ahead and do that if you want. If not, just watch. All right, so here is the answer. We're imposing a new kind of carpet. So this is an experiment because there is a treatment being imposed. At least it seems so to me. All right. For convenience, the apartment building owner wants to use a cluster sampling method in which the floors are the clusters to select 8 apartments. All right, describe a process for randomly selecting 8 different apartments using this method. All right, so you've got 9 floors, right? And remember what a cluster sampling method is. All right, what you have to do is you have to take a large assortment of things like this apartment building and then randomly pick, in this case, floors. And then when you pick a floor, you're going to have to conduct your study in everything in that floor. All right, so you would let's see how this would work. All right, use a random number generator and select 2 numbers from 1 to 9. Make sure they're unique, right? Then carpet 4 apartments on the 2 floors. All right, then you can do your study from that point on. All right, last thing. An alternative sampling method would be to select a stratified random sample of 8 apartments where the strata are apartments with children and apartments with no children. A stratified random sample of size 8 might include 2 randomly selected apartments with children and 6 randomly selected apartments with no children. In the context of this situation, give one statistical advantage of selecting such a stratified sample as opposed to a cluster sample of 8 apartments using the floors as clusters. Okay. All right. Children may have a bigger impact on carpet wear. So if you're going to get samples without any children, you're not going to really get a good view of how quickly this new carpet wears compared to the old carpet. So since wear and tear on the carpet may be different in apartments with and without children, you would be guaranteed to have both represented using a stratified random sample because you would split the sampling frame into 2, ones that have children and ones that don't. And then you would pick your however many, 8 apartments, and you would be guaranteed to get as many, I would probably do 4 of each, right? You could do 2 and 6, however you want to do it, just so long as you make sure you get some with and some without. So in a cluster sample, it is possible to get 8 apartments where no children live. All right, so you can see this is kind of how AP wants these things answered. All right, let's move on. All right, in an ultramarathon, as you might guess, this is a foot race longer than 26.2 miles of a marathon. Runners commonly develop respiratory infections after an ultra marathon. Will taking 600 milligrams of vitamin C daily reduce these infections? Researchers randomly assigned ultramarathon runners to receive either vitamin C or a placebo. Separately, they also randomly assigned these treatments to a group of non-runners the same age as the runners. The subjects were watched for 14 days after the race to see if infections had developed. Explain why this is an experiment and not an observational study. All right. This is an experiment because researchers imposed a treatment, vitamin C or placebo, on the subjects. Simple. Identify the explanatory and response variables. Well, explanatory is whatever you're treating. So that would be your 600 milligrams daily of vitamin C or placebo, and the response would be the either number of infections developed or the proportion of infections developed, however they're going to measure them. So the response variable is the 600 milligrams of vitamin C, and the response that's explanatory, and the response variable is the occurrence of respiratory infections 14 days after an ultra marathon. See how I'm keeping the context? All right, identify the experimental design used in this study. All right, so doesn't it seem to be that you have some runners either taking vitamin C or not, then you have non-runners either taking vitamin C or not? So aren't you running this experiment twice at the same time? That sounds a lot like blocking. So this is a completely randomized block design. We performed the experiment on 2 blocks. One block was composed of runners and the other was composed of non-runners. All right? So the report said 68% of the runners in the placebo group reported the development of symptoms of upper respiratory tract infections after the race. This was significantly more than reported by the vitamin C supplemented running group, 33%. What is the meaning of the word statistically in the context of this study? All right, remember statistical versus practical significance? That's what's happening here. And what they're saying is that you would rarely see this big of a difference in the percentage, this big or higher, just by chance alone. So how I wrote it, that means that we are unlikely to get a difference, 68% versus 33%, that large or larger, just by chance. We can attribute the difference to the supplementing of vitamin C. All right? All right, this was a controlled experiment. Describe how it was controlled and explain the purpose of doing so. All right, I got pretty detailed here. So this is what I said. I said blocking, because they did blocking. This controls for systematic differences between runners and non-runners. All right. Each block had a control group receiving a placebo, no vitamin C. This controls for the placebo effect, and it provides a baseline, right? So you're getting the placebo effect with a sugar pill and vitamin C. It's just you're trying to see if there's an effect beyond that placebo effect with the vitamin C. All right? Finally, a random allocation into treatment groups gives control by hopefully spreading lurking variables equally between treatment and control groups. All I'm saying here is that if you have folks in either block that just get sick a lot, hopefully you are spreading them evenly between, the treatment for the vitamin C and the treatment with placebo, and you're not just kind of piling all of those, sickly people into one group or the other group. You're kind of randomly assigning them and hopefully getting identical groups, identical groups. Okay. All right, so bias is present in the following designs, and this will be the last thing. In each case, identify the type of bias involved and state whether you think the sample result obtained is lower or higher than the actual value for the population. Okay, so there is an announcement in the daily bulletin that student parking is going to change and come to change and come to the main office to fill out a survey whose results will be used to alter how things are arranged in the student parking lot. The survey results came out and say that 60% of all students feel that seniors should have the first 2 rows of parking in the parking lot. All right, is there an issue here of bias? It seems like it would be, because I don't know that they're randomly picking these folks and getting them in the survey at random. I think these people are self-selecting. So this is a voluntary response bias. There's no random selection. Students choose themselves to participate or not. Well, if they're going to choose themselves and they are seniors and they have a shot at getting good parking spots, then they're going to rush in and overwhelm that particular survey and skew those results. So this is going to overestimate the amount of students who feel seniors should get the first 2 rows of parking. And I'm guessing those would be the seniors. All right, very last one. A simple random sample of households in a city is performed and the head of household is asked, do you think our mayor should be run out of office for all the ways he has mishandled the finances for the city? All right. I guess that presupposes that the mayor actually has mishandled them, but I'm sure if you put that in a survey, it sounds an awful lot like he did. So an overwhelming 92% of the heads of household responded yes. I think you've got wording effects here. All right. So this is wording effect bias. It overestimates the percentage of people who feel the mayor should be removed from office. Right. And it really kind of coaxes people into answering that way. A better question would be, do you believe that the mayor should complete his or her term? Period. If they have a reason for why they should or shouldn't, they can answer based on what their prior opinion was. You're actually feeding them opinion by throwing out there that this mishandling of the finances. That may or may not be true. And the poor mayor has no defense against that. So, this is it.